According to the InterNACHI Home Inspection Standards of Practice, the home inspector shall inspect the main water supply shutoff valve, the main fuel supply shutoff valve, water heating equipment, including temperature pressure relief valves, interior water supply, including all fixtures and faucets by running the water, all toilets for proper operation by flushing them, all sinks, tubs, and showers for functional drainage, the drain, waste, and vent system, and drainage sump pumps with accessible floats. The inspector shall describe whether the water is public or private, the location of the main water shutoff valve, the location of the main fuel shutoff valve, the location of any observed fuel storage system, and the capacity of the water heating equipment, if labeled. The inspector shall report as in need of correction deficiencies in the water supply by viewing the functional flow in two fixtures operated simultaneously, deficiencies in the installation of hot and cold water faucets, active plumbing leaks, and toilets that were damaged, were loose, or leaking, or had tank components that didn't operate.
All right, we're going to do 3.6 of the SOP, which is the plumbing section. And plumbing, like all of our inspection, it's mostly a visual inspection and listening for things and stuff too. So we're going to start with the main line coming into the house in this case. And so here we see the main copper line coming up from the floor. A couple of things about this out of the gate. We put somebody put a sleeve around the copper pipe coming through the slab, which is exactly what we want to see. Whether it's simple plastic, paper, something that isolates that copper pipe from contact with the concrete for two reasons. If the concrete slab moves and it's holding onto the pipe, it can move that pipe with it, maybe break something. And the other thing is mineral salts in the concrete can react with the copper and damage the copper, weaken it, and cause a leak. So we want to see this sleeve here around it. So here we have the grounding conductor from the main panel coming in and connected to the pipe below any of the valves or meter or anything. This is the way we want to see it. And so this is the second water bond for the grounding system on the electrical. And then we have here a ball valve here that we're not required to operate these. If it's a gate valve, which is the round handle on it, don't do those at all because those have a failure rate. Ball valves are much more reliable and less likely to give you trouble if you operate it, but you're not required to. And then this is the meter. In this case, this sends, and clients will ask you, this sends a signal to out to the street so that the city can read the meter without coming inside. And then we have another valve here. Either one of these turn off the whole house. The reason there's two is at the time of construction, they put two valves here so they could isolate the house and the supply coming in to add the meter here. And then on this house, we also have a backflow preventer or check valve added here, which isolates the house from the city system. So the house is on a closed water loop here. Water comes in and cannot return to the city system. So because of that, as we look up here on our water heater, above it, we have an expansion tank up here. And the reason for this is there's two types of expansion control systems we have. One is an expansion valve, which we don't have on this house. An expansion valve relieves excess pressure and diverts that pressure by literally running water to a floor drain. Or in this case, we have an expansion tank here. The reason for this is when the water heater is heating water, it can dramatically increase the water pressure in the house, and by a lot in some cases. And so we want to absorb that excess pressure by some way, and in this case using an expansion tank, which has a rubber diaphragm in it. We have air in the bottom of it, and then we'll have water in the top of it. You are not required to check these. I usually do, because they have a very high failure rate. So I unscrew the cap here over the Schrader valve, which is just like a car tire valve, and I'll just take my thumbnail and And what do you know? I got a little whiff of air, and I just want a whiff of air. If it sprays me with water and air, I'm thinking maybe I just have a little condensation in here or something, not a problem. But if it just sprays me with pure water, I'm thinking the diaphragm in here has failed and we need to replace this. I don't check it for air pressure because that would require me turning off the water to the house, draining the house down, and then checking it. But for your information, normally this is inflated by the plumber to the same water pressure as the house. So this looks good here. So while we're all standing here with our water heater, we see right out of the gate we have foil tape up here on the flue, and once again, foil tape not allowed in most areas. It hides the quality of the connection, and it's not approved for use most of the time. And so we would call that out as a defect. So I would take my camera and take a photo of that. Even if it's a minor defect, it's still something we want to point out. So here we have our main water line, cold line, coming into the water heater. We have a valve on it, have a little bit of green up here, which is nothing, that's normal. Sometimes we'll see mineral deposits around these that are dry, indication that maybe there was some past leak, but they sealed themselves. Take a photo of that, make a note that there's past leakage, currently dry. And so we check our connections to our water heater. Here we have a dielectric nipple on each connection. That's looking good, no corrosion there. That's what we want to see, very good. As I'm looking at my water heater here, I have a label on it, which is always nice to take a little photo of that, just for reference. Our SOP says to note the size of the system. So how big is it? Easy to see, 50 gallons on the label. We also, in this case, have a date there, which is handy for us to give us a sense of the age. We're not required to age them, but it's nice to have a sense for how old the water heater is. Depending on your area, some water heaters can start dying as early as 7 or 8 years. Other places can go much longer. 15 around here is an average working life for a water heater, but you may be in a place where it's much shorter, or in some cases longer. While we're checking our system here, we have a cover here. This is a newer system, so it's a closed off burner down here, but we have a little window down here where we can look in, see what's going on, and I like to just get down and look in there and see what I see. This one here isn't firing right now. It's always nice to turn on some hot water, force the unit to come on, and we can see how the burner plate is burning, and sometimes see some rust or debris that has fallen in on the burner plate, which might indicate an issue, a problem going on. Little things. We have a sticker here that says do not block this combustion air intake here. Good, it's not blocked. That's a nice thing to see. Put our cover back on here. Our noses are very sensitive for smelling gas leaks, and this one's easy. I can easily just sniff it with my nose, tell if there's a leak. You can also run a gas sniffer around it and check for gas leaks. So here we have the temperature pressure relief valve, TPR valve. This is a safety device. This prevents the water heater from becoming a bomb. And so if something goes horribly wrong with the water heater, it builds up too much pressure, this relieves that pressure. There is no good reason for water to ever be coming out of the discharge pipe here. The discharge pipe should terminate within 6 inches of the floor. This one does, that's good. The end of the pipe should never be threaded. So this one is not threaded, so that's good. On our TPR valve, you're not required to do anything with it. I like to check them when I think I can safely do it without causing any risk of an issue somewhere, but something you can simply do is spin the toggle on the handle here. If it spins like that, that's a good start, indication that our valve is loose and not stuck in any way. The instructions for this valve say it should be tested once a year. Most homeowners never do that. If you're comfortable doing it, you can test it by opening it up, getting a discharge of water, and making sure it stops. And there we see it piddling out. So this one is operating the way it should. This is one of these places where know what you're comfortable doing. If you're comfortable doing this, great. If not, that's fine. You just observe the condition of the valve, not unusual, no unusual mineral buildup around it, rust, corrosion, anything like that. And one thing to check for, whether you operate the valve or not, any evidence that water has been coming out of it in the past with stains on the floor or anything like that, that would indicate that maybe sometimes this valve is opening, which might mean that the water heater is building too much pressure occasionally. But in this case, we're looking very good here with this one. So, also part of our plumbing is our gas line. So in this case, we have a black pipe gas line coming in, and here you can see they used yellow Teflon tape on it, which is the correct kind of Teflon tape for gas connections, never white. Sometimes this comes in some other colors, blue is a popular color, but never white. White is only for water, gas deteriorates it. We're looking good here with our yellow Teflon tape. We have a sediment trap here, sometimes called a drip leg, but the correct term is sediment trap. And it can be of any length. So it could just be a nub here, this one being around 3 inches long. We're good, happy with that. So as we walk our eyes up and over our gas line, we're also looking at our copper water plumbing up here. And if you have your gas sniffer with you, you can run that along these connections here and see if you get any gas leak. But again, our noses are more sensitive than gas sniffers, and we would probably be smelling it while we're standing here. While we're also here, we're checking our flue, making sure we got the proper clearances on it going up. We earlier had comments with Ray about the refrigerant line not touching the gas line here, which would be something we would like to keep that separated. And so what we're looking at here, frankly, looks pretty good. We will continue walking around here, looking at our copper, looking for evidence of leakage, checking our gas line. We want to see copper strapped with copper. Here they used a steel strap on the gas line, which is fine, and then they used plastic straps for the copper, which is perfect, so they did this correctly here, so we're very happy with that. Here we have an electrical bond for something. Oh, this is part of the cable system. So the cable guy put a bond on there for a grounding bond. Look, this is all low voltage. We don't care what they do, so that's not a big issue for us. So we're looking pretty good here. So we're done with this area here. We have a basement bath here, and the bathrooms are part of our plumbing inspection, so we will go over to the bathroom and see what we have going on there. So here we are in the basement bath, and here we're going to just run some water, see how things are working. Our toilet here, check the flush. No, right out of the gate we see we have a broken handle there. So that's the kind of thing, even if it's minor, we're probably going to put in our report, so I'm going to take a photo of that. And then always worth a quick check in the inside, see if there's something funny going on there. This one is actually very clean. One thing, toilets are supposed to be sealed to the floor, and by the way, that means sealed completely around the base. And an easy way to check that is to take my screwdriver and go around the edge. I don't have any caulking there. Oops, that's a mistake. We would recommend sealing. And another little trick for checking to see if the toilet is tight to the floor, because you don't want to use your hands on it. Just put it between your legs and rock back and forth and see if it moves. If it doesn't, and this one didn't, good. Have have our water valve coming in here. Looks fine. No, we don't normally operate that valve at all, so that looks good. You have a, by the way, on this one here, we have a cap there. That cap is undoubtedly covering an access point to the plumbing system, the DWV system, drainage, waste, and vent system. We have several of those around the basement here. We'll look at those in a second. We're not required to pull those covers off and look in there. They're usually painted over, and no compelling reason to open that up as a rule. So over here with our sink, run some water. I like to close off the stopper if it'll close off. I like to add some water to the sink. I'll fill it to the overflow holes. In this case, this is a steel sink. Steel sinks typically are a little more vulnerable to having problems underneath than ceramic sinks. So I'll run some water in here while that's filling. I'll come over here to my shower and I start with a visual inspection of it. I'm looking to see, do I have any issues? And I have a minor one here with a crack in the pan that looks mostly superficial, but I'm going to take a photo and make a note of that in the report so that a client will know that I saw it and did not think it was a big deal. Could use a little caulking repair in that same corner, but it's pretty minor. Then I'm looking for voids in my grout or any issues with that. And then something I like to do, particularly on the handle side, tap on the tile around it. If you hear clicking, it indicates that the tile are loose. A solid dud like we have here is a good sign that they're properly attached. So that's good. We have our sink running, so it's a good time to run our shower here. Have decent pressure, but we'll turn off our sink and see if we get a major change here. Just slightly. So that looks pretty good. I'll run this for a minute to see if it gets hot. Tells me that the fixture was put on properly. Don't have a hot-cold reverse. And the other thing, I will hold it on hot for a moment and just make sure it's not too hot. We never want it above 120 degrees. If I'm suspicious that it's above that, I will go grab a thermometer and double check it to see what the temperature is. These new fixtures have a adjustment in them so that the temperature of the water, it will mix inside the fixture and you can adjust it so that you don't have it running too hot. That's important for mainly kids. So this one's doing good. So now I have my sink full of water. I like to release the water in the sink. That pressurizes the drain, and if it's going to leak, this will make it leak. And it is not leaking, so we look very good here. So we have stopcocks or shutoffs on the water supplies, which we always want to see to isolate the sink. And while I'm at it, I'll check to see if drawers work. And dead front there. And hinges on our doors are good. And even though it's part of our electrical, we'll always check the outlet since I'm standing here and see if it's connected to a GFCI. And what do you know? We got the same problem we had up in the kitchen. Some polarity issue with the disconnect, and it's showing on it a hot neutral reverse after I hit the test button. So this would be a defect that we would include in our report, even though that's technically the electrical section. I'm looking along my countertop here. The caulking is a little loose there. I would take a photo and just recommend improving the caulking. One more thing here, check the vent fan. Sounds like it's working. Not required to determine if it's correctly terminated outside, but I'll usually look for that when I'm on the outside of the house to see if I can confirm that, particularly on basement finishes, more than other places in a house, they may not have ducted the vent fan to the exterior of the house like it is required to be. But right now, that looks good. So that concludes this bathroom, and we have some more bathrooms to check also. So while we're here in the basement, we have this little cover here. This is, again, almost certainly over a clean out access point into the DWV drainage waste vent system. Clean outs must be accessible, and so this is what we like to see. It's better than just having a hole in the wall. Again, no requirement to take that off, take a look in there. Just you understand that that's what that is, a cover for the clean out access. And we have probably some more around in the basement as we go around, but just letting you know that's what that is. So, well, this one's got a different type cover on it. Same thing, clean out cover. So good, required. If you do happen to have reason to believe that there's no access to a clean out, or you can just tell the way they finished, maybe looking inside a wall that there's no access to it, call it out. It's a defect. And now we'll go look at a bathroom. So continuing 3.6 of our SOP on the plumbing section, we're in the master bath here now. And so among the things we have here is a jet tub. So with a jet tub, first of all, just kind of do your visual inspection of it. I like to test the pump. We have a pneumatic switch here. Okay, I know the pump's working, so that's a good start. So I'm going to close off the stopper on it and start it filling. And so I'm going to fill it up until the water is 1 inch over my highest jet. And that way it's not going to blow water around the bathroom after I turn it back on. Okay, we filled our jet tub up, and so now we're going to check it and see how it's running. So once again, press the pneumatic switch. I got good clean water coming out. I'm not getting any mold coming out, which is what we want to see. By the way, these knobs here control bubbles, and sometimes you're explaining that to clients. So we're looking pretty good here. I'll turn it back off. So there must be an access to the plumbing and the pump in a jet tub. And now that I got the water off, we do see a little scuzz in there. You can see some black specking in there. That's mold inside the plumbing. So I will be recommending to the client that they run jet tub cleaner through the jet tub. This stuff is cheap, you can buy it anywhere. And I'll take a photo showing my little bits of mold in there. So in this case, the access is in the cabinet. Not exactly convenient, but I will stick my head in here so we can see right out of the gate that it's powered by a GFCI protected outlet, which is what we want to see. It must be on a GFCI protected circuit. And I'm going to take my 3-light tester and see if that is working right. Perfect. That's what we want to see. I'm going to take a look at the pump on this one, which is hiding back in here. They have it bonded. There's a lug on the pump for a grounding conductor, and that is attached, which we want to see. It's a little hard to see that on this one. And then I'm going to look to see if there's any evidence of leakage, which is hard to see on this particular one. And then I'm going to take a photo of this just as reference. So this is the kind of things we look for with a jet tub, and about all we can see or do. So now I will roll up my sleeve and let the water out of the jet tub. So one thing I see as I'm looking at the tub is I can see here that our caulk line has broken loose. Could be that over time the weight of the tub has pulled it, or keep in mind that the material that the tub is made out of is different than the tile, and you have differences in thermal expansion and contraction between the two different materials. But I don't think that's any big indication of a problem. I just think we need a caulking repair done there. And I will, of course, take my photo showing the caulking repair is needed there. I'm looking at my window here, which looks pretty good. And so now kind of back into the regular routine here. Check the toilet. I'm going to check and see if it's nice and tight. It is. Take my big screwdriver, check the bottom, make sure, see if I have any caulking hiding under there. And I'd get a dull kind of, and I'd feel it squish against the caulking if it was caulked underneath. I don't get that. I'm thinking it's not sealed or caulked to the floor. I call it out. Take a quick look inside, of course. See how it flushes. Looks good. Take a look at my sink here. We have a GFCI here, which again is part of the electrical, but I'm here, so I'm going to be checking it. Oops. This one may be, this GFCI may be controlling our basement. Yeah. So it's probably controlling our basement bath also. And since I tripped it remotely from the basement bath, it's tripped here. Dead there, showing hot neutral reverse here, which is an indication it's wired incorrectly. We saw similar things in the kitchen, indication that the same guy did the wiring here and didn't know what he was doing, but that's not our issue. We just write up what we see. So, checking our sinks again. I'm filling them up like I did below. And then I'll check the drain and see how it's doing once I get these full. Also, I'm going to turn my tub back on quickly here and run my shower and see if I get a decent flow of water on my shower. I have a little loss of flow there. I'm going to turn this off. We'll see how much it improves if I turn these off. Not a big difference. I don't have a concern here because even though that's not exactly a hard shower and may have clients say something about it, it's not an issue with too many fixtures running. It's just an issue with the individual shower head here going on. So I'm going to refill my sink, get my sinks going again here so I can fill them up. Check my shower while the sinks are filling. So something we see here is we had some moldy caulk, and instead of scraping that out, they came in and caulked over the top of it, and that moldy caulk bleeds through the new caulk. So I'm just going to make a note of that in a report and with my photo, that is what is going on. And then once again, something we did downstairs, I'm going to turn this faucet on hot and see how hot it gets, and confirming that the fixture is set right. Does not have a hot-cold reverse on it. Very good. One thing you can also do, you can check the temperature of the water coming out of the water heater. If the temperature coming out of the water heater is under 120 degrees, you know you're going to be good at all your fixtures in the house. And you're out of the gate going to be good there. So we got our sinks filled to the overflows. We'll shut them off. Open this one up here and see if we have anything going on. Nope, looks good. Valves, everything looks good there, no leakage. Do the same over here. And we look good here also. Valves look good, everything looks fine, so that's all good. I'm gonna check the drawers real quickly. This one is a fake drawer. See how these all work. Nice, 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 good. Looks good along my countertop here. Yeah, that's nothing. I think we're good here, so that all looks good. So we're looking pretty good here, except we need to have the plumbing in the jet tub cleaned, re-caulk around the tub, caulk the toilet, and definitely wiring issue, because that's a safety issue. So that's a big one there, is getting that fixed. And possibly some caulking repair in the shower, but the caulking is sealed. It's just we have the mold, old mold, peeking through the new caulking there. So that wraps up this bathroom. We'll go to the kitchen. We'll check the plumbing in the kitchen at the sink and stuff there. So we're moving into the kitchen here. We're going to check some of the plumbing in the kitchen. So we're going to go over here to our sink and immediately just run the water. This one happens to have a spray head on it, so I usually do that little action there to see how it's doing. Make sure it's got the hot cold going the right direction. Although on one like this, it doesn't really matter that much. It kind of depends on how you want to handle the handle. So just, do we have hot or cold on this one? Turns nicely. So while that's running, I'll let it run. There's the cold. I'll let it run long enough to make sure we got good hot water going. So we have switches here, disposal. I'm going to shut this off for a second, take a quick peek in here at the disposal blades. And the disposal guard there looks good. That's the rubber fingers at the top. And turn this back on. I'm still waiting to get good hot water here, so waiting to see what we have there. I think this is a light switch. Yep. I'm finally getting hot water here. So just telling me it's a long run from the water heater here, but now I got hot water, so I'm happy there. So now I'm going to look underneath the sink. Right out of the gate, I noticed that the discharge tube line from the dishwasher is running directly into the disposal. The manufacturers recommend what's called the high loop method, where the tube loops up to as close to underneath the countertop as possible to reduce the opportunity for dirty water in the sink to drain back toward the dishwasher. Now the dishwasher, and certainly this one, has a check valve on it, but nevertheless, manufacturer recommends a high loop method. So I would and will take my camera, take a photograph of this, showing that we should recommend doing the high loop method for this. Also under here, looking to see our wiring to our disposal looks fine, and our plumbing looks okay. So they have a separate drain here for the dishwasher that they didn't use. Shame on them for that. In this case, that would solve our high loop problem if they had, and quite frankly, I'm going to take a photograph of that, and I'm going to have to write a little essay in my report explaining that they did not plumb this correctly, because you should not use the knock. In some areas, some jurisdictions, municipalities flat out say you can't hook the dishwasher discharge into the disposal if you have the alternative drain set up there. So in this case, it's certainly the best practice and smart. For one thing, that P-trap that we see there can dry out, and we can get sewer gases leaking into this kitchen. With the discharge going into the discharge vent here, as it should be done, that would keep the P-trap full of water and prevent sewer gases from backing into the house. So sometimes it takes a little essay to explain this stuff in our reports, and I see an essay in the future here. Also, just for interest here, we have a air admittance valve on the plumbing vent here so it doesn't have to vent to the outside of the house. That's that white gadget at the top there, AAV, air admittance valve, and that looking good there, so no problems with that. So otherwise, except for our issues with the dishwasher discharge, that is no problem here. And by the way, we can have a PVC elbow on our ABS other fixtures here because they're not glued together. They're just strictly screwed together here with the couplers, and that is okay. So we're looking okay. And by the way, that is not PVC pipe down there at the bottom glued to ABS. Somebody textured and painted the ABS, so we do not have a issue there with the way that is put together. So to wrap up our plumbing section here, we're also going to take a look at the gas meter, which is on the outside of the house. So in this case, you know, homeowners got some stuff piled up against it. Our SOP does not require us to move these things out of the way, but in this case, it's nothing, you know, it's not going to be a big job to kind of pull this away for a little bit and take a look at it. So a couple of things here about this. The human nose is more sensitive than a gas sniffer. So I like to just take a quick sniff around it, see if I pick up any gas. If I do pick up a hint of gas smell, I'll wait a few minutes, come back with my sniffer, my gas sniffer, and now check it. Because this is a pressure relief system here. And so if there's a surge in the gas pressure to the house or something, it'll discharge that surge through the bottom of the relief here. So sometimes we have the good fortune, if you will, of being here just as it's releasing a little bit of overpressure out the vent here. So I'll let it do that, come back and check it with my gas detector and see if I'm actually finding a leak somewhere. The other thing is our little wire down here is a tracer wire. Remember that the gas line from the street is PEX, it's plastic. So if they're trying to do a locate on it, they can't energize that plastic line, so they run a wire along the side of it, and they can energize that wire and locate their gas line out in the yard for whatever reason that might be. Otherwise here, it looks stable, it's nice and square, it's not twisted off to the side or anything. We're looking good here on this gas meter. A little rust on our gas piping here is not considered a concern. So with checking the gas meter, this concludes our plumbing section 3.6 of the SOP.